Aloha and welcome to this short screencast on GitHub Desktop. It's the tool that GitHub provides to make using Git with its particular hosting service a lot easier. And hopefully by the end of this video, you'll be convinced that GitHub Desktop is easy and fun to use. So some of you may be used to using Git from the command line. And that's really good for advanced uses of Git where, for example, you might have 5 people with local repos and you're pushing and pulling from different people's repos and maybe doing mirroring or rebasing, stuff like that. But in this class, we have a much simpler workflow, although a workflow that allows you to build fairly sophisticated work products, where GitHub will be kind of a central repository and people won't push and pull directly from each other. Instead, they'll all be pushing and pulling from GitHub. And so it's kind of like a star configuration. So I highly recommend, even if you like the command line, that you spend some time this semester using GitHub Desktop, because there's a couple features in there that you can't get on the command line that you'll find is really quite useful. All right, so ultimately, you're going to basically do your stuff with 2 tools. One is GitHub Desktop for the kind of the repository management stuff, and then when you come into merge conflicts, you will use IntelliJ IDEA to resolve the merge conflicts, because there's a very nice multi-pane window for dealing with merge conflicts. But for this short video, we're not going to worry about merge conflicts, because at this point in the semester, you're just working by yourself. And so it'd be kind of crazy to have merge conflicts when there's only a single person working. So you're not going to get into that problem yet, hopefully. Unless you're working from 2 different laptops, then you can certainly get them. But we'll get to the merge conflict soon. But for today, I want to give you a gut feeling for what is clone, push, pull, fetch, create. What do all these things actually mean? Okay? So the canonical workflow, the simplified version of the canonical workflow for this class, is that you'll always create your repos on GitHub. Then you'll always clone them to your laptop. And starting next week anyway, you'll be creating an IntelliJ IDEA project to edit the repo files. And starting next week anyway, you'll create a .gitignore file to prevent these project files from being committed, because you can't share IntelliJ IDEA project files between users when they're working on different platforms. So it's kind of junk. But then you'll be using GitHub Desktop to commit and push project files back and forth. So I'm going to show you this stuff, and I'll show you a little bit of IntelliJ IDEA, but we're not going to use kind of important features from IntelliJ IDEA for this week. The main thing is I want you to get the feeling for creating something on GitHub, getting it local, making changes, and pushing it back onto GitHub. And if you have that understanding really solid in your mind for this week, that's great. All right, so let's look at the basic Git concepts. We want to create a repo. Here I am at GitHub in a browser. There's a new button right there. You can see it. And so I'll click that, and then it'll ask me to create a new repository. And I give it a name. I'll give it the name foo. I'm going to make it public, although often in this class you'll make private repos. I'll definitely want to initialize it with a README. And then I'll click the Create Repository button, and I get something like this. Okay? So that's the sequence of steps in the browser, but let's think kind of more graphically about what happened. And what I'm going to do is show you over at GitHub, which is referred to within GitHub Desktop as the origin, which is kind of a technical Git term, but you just, for the purpose of this class, origin and GitHub are always going to be the same thing. They don't have to be, but they will be in this class. And over at GitHub, we've just created a repo. I'm going to represent that by a cylinder, and the name of this repo is foo, and it happens to have a single file contained in the repo, stored in some crazy fashion, and it's called readme.md. So the second thing we want to do is we want to basically be able to manipulate that repository, and in order to do that, we're going to clone it to our laptop, because right now it only lives out there on the GitHub servers. So to do that, we're going to click the clone or download button in the browser, select Open in Desktop, which should open up the GitHub Desktop, and we'll choose a local path that does not contain directories with spaces. For reasons that are, not worth going into here, your life will be much better if you do not have paths to project files that contain spaces. So in Unix, Mac OS land, no problem. But in Windows land, depending on your version of your operating system, you may have a directory called document space and space settings. That's a directory name with spaces. Don't have any of those, okay? I basically like a top-level directory called GitHub with an interior directory, which is my username on GitHub, Philip M. Johnson. I put all my repos inside there that are associated with the Philip M. Johnson repository. I also have other organizations in GitHub that I'm a part of, like Open Power Quality. So I have other directories inside GitHub for the other organizations that I am associated with. For this class, it's good. You could just have GitHub, but I think it's it's more scalable if you have GitHub / and then your username. Okay. So how do we do that? We press this clone or download button in the browser. It says clone with HTTPS. That's good. And we're going to click this Open in Desktop rather than download zip. And that will bring up our local GitHub Desktop application. And it's showing this local path right here, which I've used the Choose button to make sure that it is a local path that does not contain any spaces. And for me, it's basically my local home directory. There's a top-level directory called GitHub, and then there's a directory called Philip M. Johnson, and then I'm going to put it into a directory called foo, which is the same as the name of the repository, which is just kind of the standard thing. So after I press clone, it kind of grinds away for a little bit, and then Git Desktop looks like this to say now we have this repository foo, and if we go out into our file system, you can see that not really that easily, but you can now see that there's a foo directory, and it happens to be inside the Philip M. Johnson, the GitHub / Philip M. Johnson directory. There's a README file, and then there's this .git directory that's kind of hidden, and that's where the repository is actually stored. Okay, so here's where things get a little complicated, not super complicated. But what just happened is we had our repository with a README file in it at GitHub. We invoked the clone method, and that meant over the internet, through the magic of Git and GitHub, we created the same exact repository, a copy of that repository locally, and it's stored in the .git directory. And now we have this other thing called a working tree, which is a directory called foo. It's got this directory you should not edit because that's the repo. And then it's got a file, readme.md, which is actually the contents of the readme.md. And that file you can now edit. It's accessible to you. Okay, you can't really generally get inside these repos. And you can see that readme.md is the same color yellow in all of these three cases, meaning that it's the exact same. The file is exactly the same in all of these three places. Okay, so locally we have this notion of a working tree, which are files we can edit, plus we have this idea of a repository, which is a storage area, and what we're going to do is we're going to go back and forth between GitHub. We're going to be pushing and pulling these repositories. Okay, so let's edit the README file and add a file called .gitignore. We'll get further into this next week, but for now, just let's fiddle around with our working tree. So I create a project in IntelliJ IDEA, and you can see it's associated with this directory foo. There's it hides the .git file because it knows that you shouldn't be editing that, but it does show you a project file called .idea, a project file called foo.iml, and then there's this new file .gitignore that I created, and I've edited the README. I've added the line, "This is my sample project." You can see in the .gitignore file, I'm ignoring my IntelliJ files. Again, for this week, when you're just getting started, just think of this as a file like any other. Basically, this is going to prevent certain files from being committed to the repository. But we'll get to that in more detail next week. Okay, so after doing that editing, what just happened? Well, GitHub hasn't changed, and in fact, my local repo has not changed either. What has changed is I've edited the files in my working tree. I've edited that readme.md file, and I've created a new file that happens to be called .gitignore, and I'm representing the fact that they're different by giving them a different color. Okay, so all right, that's great. And now what you can see in GitHub Desktop, if you brought that up, is you would see that it is telling you that there are two files that are changed, and in fact, you can click on each file to see exactly what has changed about each of these files. This is the first place where using Git from the command line is not nearly as nice as being able to click through the different files. We can also see that .gitignore was an added file, readme was an edited file, and you can tell that based upon the different icons. Okay, so all of that stuff is nice. It also tells us we're in the master branch. We'll get to branches in a couple of weeks. And the repository we're currently dealing with is foo. Okay? All right. So we've changed our working tree, but let's say we want to actually save out these changes to GitHub. Okay, how do we get them from our working tree all the way to GitHub? And there's basically two steps. The first step is to copy the changes from the working tree, from the files in the working tree, into our local repository. That's called committing. So we'll run the git commit command to do that. The second step is to, now that we've updated our local repository, we want to upload the local repo contents to the remote GitHub repo, which is referred to as the origin. Okay, so let's look at the git commit. You must provide a comment, otherwise the commit button is disabled. When we look in this interface here, you can see that, oops, okay, that that after doing this, I typed in a command, and after doing it, I pressed commit to master, and we can say that my summary string was update the README, and it now indicates that I could press this button to actually push my changes in the local repo up to GitHub. Okay. But let's look and see what we just did. What we basically just did by running the git commit command within GitHub Desktop is to instruct GitHub Desktop to take these changes to the readme.md file and the .gitignore file and put them into our local repo. So now our local repo looks like this, but the GitHub repo is, of course, not updated yet. So that takes us to step 2, which is to do a push. So commit is basically from the working tree to the local repo. Push is from the local repo to GitHub. Okay, so if we take this button, and you can basically see this little icon here says there's been one commit to the local repo that could be pushed up to origin. That's what the little up arrow looks like. So if we press that press the push origin button, there's some stuff that happens, sorry. And after 5-10 seconds, you can see it says fetch origin, which indicates that the commit has succeeded. And now if we were to go to the browser to look at the contents of the repo at GitHub, we go here and we can see, we can see this is my sample project. That text which I edited locally is now available at GitHub. Okay? So here's what happened when we pressed that push to origin button. It basically took the contents of our local repo, which had been updated from our working tree, and pushed it up to GitHub. All right? So there's a couple of things you're going to say, fetch and pull, and this is all about getting changes from GitHub back down to your local repository. So far we haven't had any of that. We've just had creating it, right, and cloning. But as if you work on multiple laptops or if you're working with other people, there'll be times when the GitHub version of your repo has been changed by other people or by yourself working in some other environment, and you want to pull down those changes. The cool thing about GitHub Desktop is when it's running, it's monitoring the origin repository, i.e. GitHub, and it will automatically do a fetch if it changes, which means it will copy any changes from GitHub, the GitHub repo, into your local repository automatically. This doesn't change your working tree. It doesn't change the files that you're working on. Unfortunately, that would be crazy. But it means that it knows about the changes and you can see the changes. Okay. In order to actually get those changes into your working tree, use another command called pull. So let's pretend I'm working in another environment. I'm going to simulate this by actually just going into my browser, and I'm going to edit. I'm going to add the line, "I am really excited about this project," to my README file, just using the browser-based editor, and I'm going to commit that to my master branch, and I added a little commit message. And so after committing that, what you can see is at GitHub, now my README file has changed. It says it has this "I am really excited about this project." But of course, that's not yet available locally, right? Because I haven't done anything to get that change. To represent this fact that the README file is now changed on GitHub, I've made it blue text. Okay, but locally here we have red text. It doesn't include that sentence. So what you can see if you go back to GitHub, and you might have to wait a little bit of time because it doesn't check like every second. It checks every, I don't know, 5 or 10 minutes. But it will automatically do a fetch every once in a while, and it's done that, and it now shows that in fact there is a change, there's a commit at the origin that has been fetched into my local repository, a single commit, and that if I want to get that into my working tree, I can click this button to say pull origin. All right. So what's happened is the fetch command has taken any changes from the origin repo and put them into my local repo. So now the updated version of readme.md, represented by the blue text, has gone from from GitHub to my local repo, but unfortunately fortunately or unfortunately, my working tree does not show those changes yet. Okay, so you can manually fetch from the origin. You can just press that button, or GitHub will do it automatically every few minutes. Okay, so here we are, and we can press the pull origin button. And having done that, it looks like this. And now you can see if we go into our editor and look at the README file, you can see locally I now have that text. I'm really excited about this file. So here's what happened graphically. We invoked a pull, which took the text, the changed readme.md file from our local repo. It happened to be stored in the .git subdirectory, but that's neither here nor there. And now the files that we actually edit in our working tree, this readme.md is the same. It's in blue, indicating that it's the same everywhere. All right, there it is. That's basically the workflow. So I'm going to quickly summarize all of these different Git commands and how you're going to use them. To start, you use clone when you want to copy a repo from GitHub that you've presumably just created to a directory on your laptop. So you clone when you don't have the repo locally already and you want to get a copy of it. And the clone command will both create that repo, plus it will create the working tree. So it'll take the master branch typically and extract all those files and make them available to you there so you can work with them. The working tree is the directory in your file system where there are files that you can actually edit, or you can add files, you can delete files, do anything you want in there. Commit is the process of taking the files, the new files, deleted files, modified files from your working tree and pushing them into your local repository. Push is the process of taking all the, whatever modifications are now in your local repository and copying them up to GitHub's repo. Fetch goes the other way. Fetch is saying there might be some changes at the GitHub repo that you did or somebody else did that's not available locally. Let's bring those changes down into your local repo. And then finally, pull is to take those changes in your local repo and actually put them into your working tree so that they're available for editing. Part 2, dealing with branches, merge conflicts, all that stuff. Separate screencast for that, but hopefully this will be plenty to get you started for now.